Right, okay, guys, here we go. Session 16. Carrying on with differentiation. We've got two more sessions on differentiation, and we're going to look at stationary points today. Let's go. Right, okay, so the first thing you need to know is what a stationary point is. Okay, now a stationary point, is when the gradient is equal to 0, or dy dx, the gradient function, is equal to 0. That is what a stationary point is. It's easy to see if we've got a graph. Now we might have a graph of any sort of state. The stationary points are basically the bits at the peaks and the troughs. So that would be one stationary point, and that would be another. These are stationary points. Okay, and there's two types of stationary point. This one here is a maximum because it's in a peak, whereas this one here we would say is a minimum because it's in a trough. Okay, it's not necessarily the minimum value on the graph, but it's where it's going into a dip. Right, so we need to work out how to work out what those are. Now the second derivative, remember, which is d2y over dx squared. Just while we're on that, just a thing to note, I should have mentioned this earlier, but the second derivative is not the same as the first derivative squared. That's a really important thing to note down. It's a completely different thing. You differentiate it twice. It is not dy dx squared. So the second derivative tells us the nature of each stationary point. Okay. This basically means where it tells us whether it is a maximum or minimum. This will become very obvious when we do an example, but for now, just get the notes down. Okay. Now, if the second derivative is positive, so if it's greater than 0, then the stationary point is minimum. That's because the gradient is getting more positive. It's getting more positive as it enters a dip. So it is a minimum if d2y over dx squared is greater than 0, and if it is less than 0, then the stationary point is a maximum. Okay, so they're the notes. It'll become much easier when we do, much more obvious what I mean by that when we do an example. So e.g. 1, y equals 2. So I've given you a function, y equals 2x cubed minus 3x squared minus 12x plus 4. Part A, find the coordinates of the stationary points. Okay, so part A, find the coordinates of the stationary points. This could be in an exam, maybe 3-4 marks. So first thing you do, you find dy dx. We find the gradient function, and the gradient function for that is going to be 6x squared, 3 times minus 6x minus 12. Okay, now if it's a stationary point, I just know that it's when the gradient is 0. So it's when the gradient function equals 0, and I solve this equation. I can divide through by 6. It's quite nice. Okay, I should be able to factorize this, hopefully. So x is going to equal, my x coordinates is 2 or -1. Okay, just solve that like a quadratic. I then need to work out what my y coordinates are. So I need to work out what y is, and I do this by plugging it into the original function. Okay, and I'm going to do use my calculator as a bit of a treat here. I'm going to type in the function 2x cubed minus squared minus x plus 4, and then I press calc, and it's when x is 2, so when x equals 2, press it again. Ooh, what was it? It was minus 16, so y is going to be minus 16, or the other one, I press calc again, x is minus 1 this time, and 11, it's just 11 there, so my 11. So my answer, my two stationary points for that curve is 2 minus 16 and minus 1, 11. Okay, let's just do a quick check on Desmos, see if this is accurate or not. Okay, let's have a look. So it's y equals 2x cubed minus 3x squared minus 3x squared minus 12x plus 4. And if I zoom out a little bit, the two stationary points, the first one, minus 1, 11. You can see there, minus 1, 11, that's good. And the second one down here, 2 minus 16. So that's a good check there. Good. Right, that's part A. Part B, determine the nature of each stationary point. Okay. Now, I can probably see straight away that this one's going to be the minimum and this one's going to be the maximum because it's just lower. This one's obviously lower than the maximum. I can also do it a bit more mathematically and thoroughly by using the second derivative. So I know dy dx, if I go back up to dy dx, it was 6x squared minus 6x minus 12. And then if I do the second derivative, differentiated again, I get 12x for that one, minus 6, then not minus 12 disappears. Now, I need to test each coordinate. So my first coordinate, I need to test 2 minus 16. That is when x equals 2. That's the x coordinate is 2. So when x equals 2, the second derivative is equal to 12 times 2 minus 6, which is 18. Now 18 is greater than 0, therefore it is a minimum point. It is a minimum point, and that's how you'd answer that sort of question. The other one was, what was the other coordinate? Minus 1, 11. And if I put that into my second derivative function, I get, that's going to be minus 18. And minus 18 is less than 0, therefore it is a maximum. Okay, so that is what it means by determining the nature of each coordinate, and I've done that. Final thing you might be asked to do, finally, is sketch the curve. Okay, sketching the curve, it might ask you just to sketch the curve showing the stationary points, showing the shape and stationary points. Okay, well now you've got the stationary points. You know it's a cubic, so the shape is a positive cubic, it looks like that. And I know that the coordinates are of the stationary points are 2 minus 16. 2 minus 16 is there. And the other one was minus 1, 11. Sorry, that's not in the right place. 2 minus 16 is down there, isn't it? And minus 1, 11 is up there. And then I just draw a cubic with those as it's going to be, that's our maximum, that's our minimum, and then it shoots up even higher. There's no more stationary points there. So that is good enough for a sketch just showing the stationary points. Right, okay, that's it for the learning today. It's over to you to do some questions now. So it's page 234 from the textbook, please, exercise 8F. Can you just do question 1? Now it's got different parts, A, B, C, D and E, but just want you to do the right-hand side questions. Right-hand side questions. Which is II, IV, VI, and VIII. And I also just want you to do question 3. So it's got a bit of a shorter session today, and the last session on calculus will be next week. So good luck with this one, and tune in again next time.